Hello guys, in this video we're going to talk about the test of the chapter 9 variation. So please use this video to help you to familiarize of all of the topics in this chapter. So let's do the first one. We have the A is varies directly as B minus 2. So we can write it as A is directly varies to B minus 2. So this fishing sign can change it to equal to K. So we have A is equal to K times B minus 2. The condition that we have is A equal to 12, B equal to 6. So we substitute in, have A equal to 12, B equal to 6. We substitute in our equation, so we have 12 is equal to K times 6 minus 2. Then we have 12 is equal to 4K, so that we have the variation constant, which is equal to 3. And after that, we find out what's the coefficient, what's the variation constant. We need to substitute back to our initial formula so that we have the A is equal to K, which is 3 times B minus 2. And they're asking about find the value of A when B is equal to 9. So when we have the B is equal to 9, then we have the A is equal to 3 times 9 minus 2. This one will give you 3 times 7, then it's equal to 21. So the answer will be C. So when you do the correction, please write all of the steps. Don't just give me the answers, okay? So question 2, we have the P is various as P and R squared. So every time you see this and, which means that this is a joint variation, isn't it? Jointly variation, so that we have the P is various, directly various to Q times R squared. Then we can change it to equal to K. So if P is equal to K times QR squared. The condition that we have is Q equal to 1, R equal to 4, P equal to 12. So we can substitute Q equal to 1, R equal to 4, P equal to 12 into our equation to get the 12 is equal to K times 1 times 4 squared. So now we have the 12 is equal to 16K. And the K is equal to 3 over 4. So now we get the value of the K, the variation constant. We can substitute back into our initial formula so that we have the P is equal to K times QR squared. The K is actually equal to 3 over 4. So we have the 3 over 4 times Q times R squared. So that's our relations between P, Q, and R. And now they are giving that the Q is equal to 3 and R is equal to 2. So when Q equal to 3, R is equal to 2. Just substitute in our equation found 3 over 4 times 3 times 2 squared. So using the calculator, I can get the P is actually equal to 9. So the answer should be A. So for question 3, we have the parsley variation. You see the parsley, which means that the Y is equal to something plus something. So the first part is various directly as x, and the next part is various inverse as x. So we can write it as the y is equal to k1 times x plus k2 divided by x. When you have the directly, you times them together. The inversely means that you divide them. So now we have two conditions. The first condition is x equal to 1, y equal to 1. So we substitute x, y equal to 1 into our equation here to get the value of 1 is equal to k1 times 1 plus k2 divided by 1. It simplifies to get k1 plus k2 equal to 1. So that's our first equation. Then we have second condition, which is x is equal to 2, y is equal to 7 over 2. So we substitute x equal to 2, y is equal to 7 over 2 into our equation there. So we have 7 over 2 is equal to k1 times 2 plus k2 divided by 2. So I don't want the fraction to be here, so we times the both sides by 2. So now we have the 7 over 2 times 2. So you remove the 2 from the denominator. We got 7. Then we need to use the 2 to times all the things inside the bracket. So 2 times k1 times 2 gives you 4k1, and 2 times k2 over 2. The denominator is being eliminated, so what we have is just k2. So that is our second formula. Then now we have two formula. which is k1 plus k2 equal to 1, and 4k1 plus k2 equal to 7. So you can just use the second formula minus the first one. On the number side, we have the 7 minus the 1, so give you 6, and 4k1 minus k1 will give you 3k1, and the k2 is being eliminated, so don't need to write anything about k2, so that's the k1 is actually equal to 6 divided by 3 give you 2. So that's for k1, and for k2 we can just simply substitute the 2 back into our first equation. So we substitute k1 equal to 2 into the first equation to get 2 plus k2 equal to 1, so that the k2 is equal to negative 1. Then now we got the constant, we can put it in our initial formula here. Then we can say that, so we have the y is equal to k1x, which is 2x, and we plus k2 over x, so it's plus k2 over negative 1. So we have k2, which is negative 1 over the x. Then we simplify again. We have 2x minus 1 over x. And then now asking what's the value of y when x is equal to negative 1. So I just write it here. So when the x is equal to negative 1, y is going to be equal to 2 times negative 1 minus 1 divided by negative 1. So it's equal to negative 2 plus the 1, give you the answer is negative 1. So the answer will be A. So for question 4, we have to ask the y as a sum of 2 parts. One part is constant, other part is various as x squared. So again, we have y is equal to k1 plus various as x squared. So we have k2 times x squared. So again, from 2 formulas, then we can have 13 equal to k1 plus x is equal to 1. So we have k2 here. And then the second condition, we have x is equal to 2, y is equal to 10. So it basically just substitutes the y to become 10, and x becomes 2. So now we have 10 is equal to k1 plus 2 squared give you 4, k2. So that's the first equation. This is the second one. You can, by using our the second equation minus the first equation, you can use the 10 minus 13 to get a negative 3, which is give you 4 minus 1, give you 3k2, so that the k2 is equal to negative 1. Now we substitute this k2 equal to negative 1 into our first equation. So we have 13 is equal to k1 plus k2, which is negative 1. Then k1 should be equal to 14. We now get the value of k1 and k2. We substitute it back to our initial formula to get the y value is equal to k1 is 14, the k2 is negative 1, so we have negative x squared. So that's the relationship between x and y. And now we have the x is equal to 3. So when the x is equal to 3, we have the y is equal to 14 minus 3 squared, give you the y value is 5. So the answer will be B. So question 5, this question no one get it correct, but actually it's quite easy. First of all, we have A is varied directly as B, and so it's a joint variation, and inversely as the square roots of C. So if A is various as B, and it's inversely, so we divided by the square root of C, and we can change this sign into the equal to K. We have A equal to KB divided by square root C. So they are asking about which one must be a constant, so we make K, so you can make K be the subject. And what we're going to have is the k is equal to a times the square root c, then divided by this b. So we have a square root c divided by b. So is there anything in the multiple choice that we have this choice? We don't have square roots. So means that the answer don't want the square root. So we give the square to both sides. We have k squared is equal to the whole thing squared, which means we'll give you a squared times c divided by b squared. So it actually shows in here. So the answer should be D. So y is correct because when k is a constant, k over 2 is still a constant, isn't it? So that is correct for the answer D. So moving to question 6, we have the y is various directly as x squared, and x is decreased by 20%. So now we have the y is directly as x squared. We have y is equal to kx squared, then the new x is decreased by 20%, so we have 0.8x then we need to find out the new y value, which is equal to the k times the new x squared. Then we substitute the new x is equal to 0.8x. Then we have k times 0.8x squared. Then we have the kx squared times 0.8 squared. So the percentage change is going to be using the new y minus y divided by the y. Then it's going to be equal to kx squared times 0.8 squared minus 1 minus the original y, which is kx squared, and divided by the original one, which is kx squared. So basically you can see that kx squared as a common factor, which just eliminates them. Then we just write that something that we left is the 0.8 squared minus 1. Then we're using the calculator to get this is negative 36%. So the answer is decreased by 36%. So the answer is C. Alright, question 7, we have that the r is varies inversely. So we have inversely, so we put at the denominator, we have the square root p at the denominator, and directly as cube. So we put at the numerator for q. So now we have the p is increased by 21%. So the new p is equal to 1.21p, and the q is decreased by 12%. So I have the new q is equal to 0.88q. Then we can say that the r is equal to kq divided by square root p. Then we can say the new r is equal to k times new q divided by the square root of new p. Then we substitute these two values into our equation here. We can say this is equal to k times new q, which is 0.88q, divided by the new p square root, so the square root of 1.21p. Now we can take out our original factors that we have is kq divided by square root p, then we times 0.88 divided by the square root of 1.21. And the percentage change of r is equal to the new r minus r divided by r. Then we have this as the kq divided by square root p is our common factor. So what just we want is 0.88 divided by the square root of 1.21 minus 1. And using your calculator, it's actually equal to the negative 20%. So bear in mind that if this is a negative, means it's a decrease. Okay, so this is a decrease. So the answer is either B or D, but as we want is decrease, so answer should be D. So for question B, starting with the long questions. So now we have the y is varies directly as x cubed. So first of all, we have y is proportional to x cubed. Then we can write y is equal to kx cubed. Then we substitute in the condition. We have 9 over 2 equal to k times 3 cubed. 3 cubed will give you 27. So we have the k is equal to 9 over 2 times the 27. Then we can eliminate them by 1 and 3. So that the k is equal to 1 over 3, 1 over 6. So this is the variation constant, but the question is asking that to express the y in terms of x. So we substitute back the k equal to 1, 6. Then you put it in our original equation to get y is equal to 1 over 6 x cubed. Then for question B is similar. We have y is proportional to 1 over x squared, as we said, is the inversely. So then we change the sign to be equal to k, and equal to k over x squared. Then we can substitute our condition that we have is 4 divided by k over 6 squared. So the k is equal to 4 times 6 squared, and give you the k is actually equal to 144. Still, this is not end. We need to put it back to our original equation so that the y is equal to 144 over x squared. So that's for question 8. Question 9 that we have is the z is varies directly as x cubed and inversely as y cubed, y squared. So this is a jointly variation, isn't it? So now we have the z is proportional to x squared, x cubed, but it's inversely, so we divide by y squared. Then we change this sign to become equal to k. Then we have z is equal to kx cubed divided by y squared. Then now we have this condition which is substituted in. We have 24 is equal to k times 1 cubed, which is 1. Then we divide by 2 squared. So now we have the k is equal to 24 times 4, give you 96. So the k value is equal to 96, then we can substitute back to our initial formula to get a z is equal to 96 x cubed divided by y squared. So this formula gives you the relations between the x, y, and z. So that's for question A. We express the z in terms of x and y. So for question B, they want the value of x when y is equal to 6 and z is equal to 72. So we substitute y equal to 6, z equal to 72 into our equation here. Then we have 72 is equal to 96x cubed divided by 6 squared. So that we have, we don't want this 6 squared, so we put it on the left hand side. So 72 times 36 divided by 96 is equal to x cubed. So this is using a calculator, we got 27. So x cubed is equal to 27, which means that x is actually equal to 3. So that's for question 9. Then we can do question 10. We have y is various inversely as p, so that we have y is proportional to 1 over square root p. Then we can change the proportional sign to become equal to k. So we have y is equal to k over square root p. The condition is p equal to 64 and y is equal to 72. Then we can take it in. So we have 72 is equal to k over the square root of 64. So now we have the k is equal to 72 times 8. This one will give you 576. So again, this is our variation constant. It's not the end of the It's not the end of the questions. What we want is to substitute back in to get a relationship between the y and p, so that we have the y is equal to 576 divided by the square root p. That's for question A. So question B is a little bit like tricky, because they only ask you about find the change of y, it's not the percentage change. So for those who calculate the percentage change, I'm afraid you got no marks. So now we have the p is increased from 64 to 216, so that we can say that the value is being increased to 216. So now we can say the new p is going to be equal to 216. We just substitute in to get the new y is equal to 576 divided by the square root of 216. So 216 is actually equal to, so 216, if you divide by 6, then you can get 36. And again, you got 6 and 6. So this is actually equal to 576 divided by 6 square root 6. So after that, what you can do is to use the calculator to find out the value of this. Then this one can give you, this is going to be equal to 96 divided by square root 6. And if you want to rationalize it, then we have this is equal to 16 square root 6. So that's the new value of the y. So the change of y is equal to the new y minus the old y is equal to 16 square root 6 minus our old y, which is 72. So we just minus this 72. Then this is the final answer. You can either give me the exact solution or give me the solution in 3 significant figures. So that's for question 10. Alright, question 11 is about the functions. So what's the meaning of this f2 equal to 12 mean? Which means that when the x is equal to 2, the y is actually equal to 12. So basically just like this. If you don't realize this is the fx, you can just change it to y. And so from here, when the x is equal to -1, we have the y is equal to 60. So now we have the y is a partly constant and partly varies as x. So we have y is equal to k1 plus k2x. Then we can substitute the value of x and y. Then we have the y is equal to 12 and the x is equal to 2. So we have k1 plus 2k2 as well. First equation. Then we still have the second condition. The y is equal to -60 and the x is equal to -1. So we have a negative k2. So that's our second equation. Then what we can do is to using the first equation minus the second equation to get 12 minus the -60. Then the k1 is being eliminated. Then on the right hand side we still got 2k2 minus the -k2. So simplifies, it becomes plus. So we have 72 is basically equal to 3k2. So that the k2 is actually equal to 24. Now after we're doing that, we can substitute the k2 equal to 24 into either the first or second equation to get 12 is equal to k1 plus 2 times the k2, which is 24. So we have the k1 is equal to 12 minus 48 will give you negative 36. So now we get the value of k1 and k2. We substitute back to our initial formula to get the y is equal to k1, which is negative 62, plus k2x. The k2 gives you 24, and with the x. So that's the relationship between the x and y. So that's for question A. We have to find out what's the value of the f of x or the y. So for question B, just write it here. So for question B, we need to solve the equation f of x is equal to 4x squared. The f of x is actually equal to negative 36 plus 24x. So we just write it down, negative 36 plus 24x is equal to 4x squared. If you can realize that this is actually a quadratic, isn't it? Because we got x squared, we got x, and we got a constant. So we move all of the things into one side. Then we have 4x squared minus 24x plus 36 is equal to 0. Then using your formula 0, 1, and we have 4 as the A, negative 24 as the B, 36 as the C. You can get x is equal to 3. Press again, it's still a 3, so this is the repeated root. Alright, so the answer is just x equal to 3. So that's for question 11. Then moving to the last one. So now we have this postal fee F is a puzzle of WKG of two parts. So now the one part is as W, another part varies as W squared. So we have the F is equal to the first part is K1W, second part is K2W squared. And we have two conditions, we just substitute in. Then now we can say, we just substitute these two condition in. Then we can have the F is equal to 30, keep the K1, the W is 2, and keep the K2, the W is 2, and with the squared. And now we have the second formula. We have 105 is equal to the K1 times 5 plus the K2 times 5 squared. So we can simplify it a little bit because if 2 is the common factor for the first equation, then the whole formula can divide by 2. Then we have 15 is equal to K1 plus 2K2. This becomes our first equation. For the second one, we still get a 5 as a common factor. So I have 21 is equal to K1 plus the 25 divided by 5 still gives you the 5. So we have 5K2. So that's for the second equation. Then we use the second one minus the first one. So we have 21 minus 15 gives you 6. K1 is being eliminated. 5K2 minus 2K2 gives you 3K2. So that K2 is equal to 2. So then we substitute the K2 equal to 2 into our first equation. We can have 15 is equal to K1 plus 2 times K2, which is 2. Then we have the K1 is actually equal to 15 minus 4 gives you 11. Again, this is the variation constant. We need to put it into our original formula so that we have the F is equal to 11W plus K2, which is 2W squared. So that is our answer for the general formula linked with the fees and the weight. So the question A is asking about the postal fee of a mailing of a parcel, which is 3.5 kg. So now we have the W is equal to 3.5. To find out what's the value of F, so we're just using the formula F is equal to 11 times 3.5 plus 2 times 3.5 squared. You can either use your calculator or you can take out 3.5 as the common factor. Then we have 11 times 3.5. So 2 times 3.5 give you 7, plus 11 give you 18, times 3.5 will give you, use the calculator, 18 times 3.5 will give you 63. So the F is actually equal to 63 for question A. And for question B, we have that if the fees is equal to 40, then we have the F is equal to 40. What's the value of W? So now we can substitute the F to becomes 40. 40 equal to 11W plus 2W squared. So again, this is actually a quadratic because we got a W squared, we got a W, we got a constant. We move all the things to the same side. We got 2W squared plus 11w minus 40 equal to 0. Then using the formula 0, 1, 2, 11 with negative 40, you can get the w is equal to 2.5 or negative 8. But actually, we are calculating for w, so the w cannot be, w is the weight of a puzzle. We can't have a negative weight, so the negative 8 should be rejected. So that's for this quiz. So if you have any question, don't hesitate to ask me any questions via WhatsApp. Thank you. Bye-bye.